Hi guys, so this video is a review of systems of quadratics, and we wanted to go over the exit ticket from Friday since there was a lot of misconceptions on there. So I'm going to start with my table. Okay, so I have two functions, and I just want to point out, we said this in class, but this word problem we're just going to ignore, and we're going to just treat it like a regular systems problem because it didn't make sense. You end up getting negative solutions, so it doesn't make sense for the word problem. So we're going to kind of ignore how many weeks, and we're just going to say, when will they both be the same? Okay, but we're going to ignore the context, so I'm going to kind of ignore the rest of the word problem. All right, so I'm going to start with my table. Okay, so I'm looking for where they intersect or where are they the same. Now, when we're working with a quadratic, we want to check to see, since there's a squared, we want to check to see if there's one answer or two answers. So it might intersect in two places, it might intersect in one. So I have x squared plus 5x minus 17 and x minus 5. Okay, so I typed that into my calculator, and I need to make sure I'm scrolling through to look for both solutions. So I see one solution is at -6 because this is the same. All right, but I'm going to go ahead and I'm going to write the ones that aren't my solutions also so that I can make sure that my reader knows exactly what I mean by my table. Okay, so when I look at my table, I see -17 and -10. Okay, so what happened on the exit ticket was a lot of people did this, and then they just left it blank. All right, so I need to answer the question. When are they the same? Where do they intersect? Okay, so I see an intersection point here, and I need to make sure I'm circling that. And it's an intersection point because my y values are the same. And I see another intersection point here. So I can automatically write that the solution to this system is x equals -6 and x equals 2. So no matter what way I solve it, from here on, I should see the intersection points at x equals -6 and x equals 2. All right, so then we saw a lot of difficulty with the graph. So let's take a look at the graph. Now, because these numbers are larger, I'm going to count by 2's on my graph. So that way I can fit everything. So they don't always have to go by ones. You can scale if it doesn't fit. So let's go ahead and plot the quadratic first. So I have -6, -11, -5, -17, -4, 21, all right. The 23 still doesn't fit. -121 does. 0, 17. 1, negative 11, that's up here. 2, negative 3. All right, so it's a little cut off still, but I'm able to see a bit more. All right, and I need to label that, so that was g of x. Okay, now I'm going to plot my other one. Negative 6, negative 11, that's where they intersect. And then this just goes up 1 over. Okay, and that is f of x. Now again, we're looking for where they intersect. So I see that they intersect when x is equal to negative 6. Negative 11 is a y, and this x is to negative 3. So I'm circling it, and I'm labeling the points of intersection. Okay, lastly we have algebraically. When I'm doing algebraically, I saw a lot of people just take the quadratic and dive right into the quadratic formula. But before I can do that, I'm working with a system, so I need to use both equations. And I need to set them equal to each other as step 1. Step 2, I'm now going to get them equal to 0. So I'm using inverse operations here. And now I have a new quadratic. This is the quadratic that I'm using to solve algebraically. Now I'm just going to do factoring because I think it's a little quicker and I want to recap factoring. So my product sum is negative 12x squared and 4x. The factors that multiply to negative 12 and get me 4. Okay, would be 6 and negative 2, these ones. These are my magic numbers. I go into my table. X squared, negative 12, 6x, and negative 2x. Now we fill out the outside. So x times x gets us x squared. X times 6 gets us 6x. And this would be negative 2. All right. I set this equal to 0. And I create my mini equations. X plus 6 equals 0. X minus 2 equals 0. Inverse. And I should get my two solutions of negative 6 and positive 2. So no matter which way I solve, I'm seeing that negative 6 and that positive 2 in all of my answers. Okay? So that's how to solve a system using all 4 methods. All right? Please, please, please study. We are going to post the Jeopardy so you can use those practice problems as well to if you want to get extra questions for your studying. All right, see you tomorrow. There's also office hours Tuesday morning at 8 if you want to come in and study questions before your exam. Bye.